Okay, so we just looked at this file. I just reopened it as it was untouched before. And we reviewed um, checking why this was extruding as an open shape. So what I did was extrude the surface. Here, I'll just do it again really quick. And then go ahead and say okay. And see, it's open, it's not closed. So the first thing I do is if there was an opening anywhere in the middle here, that's when you see these seams. But I can also see that dark seam right there. It also just indicates, hey, look, there's something going on there for me, because that's different than a normal seam. So I zoom in and I go, oh, look at that. That line was overlapping, which creates your chain was an open chain. It's not really a legitimate closed solid. So I'll back up once. What I did was just grab the quick trim and I went into each one of those corners and quick trimmed off that little piece. That makes that a nice proper closed edge there. And then that will now extrude as a solid. Let's extrude it and look at it. So yes, that's a solid, what someone would be expecting. But then I also wanted to point out another thing, and it has to do with it's just a good modeling tip in general, is so when I extrude that, see this seam right here, seams will affect all types of other intersection calculations with booleans, various booleans, especially fillet. That's a common issue with fillets is those seams, when the fillet has to run across the seam, various different types of circumstances can cause you to get you won't get a good fillet. I mean, you'll get an error saying you can't fillet it. And the reason is it's a very complex calculation for the fillet engine to eat up seams in certain circumstances. So here's an example of that. So here, I'll just take this. You have that seam there. I'm going to just try and fillet this edge right now, which is going to make a round going across that seam, right? So let's say, oh, you wanted to put a 1/4 inch 0.25 radius fillet there. I do that and I get an error. What the heck? Bobcat can't do it, you know? So if I drop down to a 0.01, for instance, then it fillets. You see how the fillet starts moving closer to that though? So 0.015, right? I just went up just a little bit and it arrowed 0.0125. And so what's happening is, see, so now that distance between the 0.015 and 0.125, once I get to the 5, is trying to go over that seam edge. And the filleter having to know how to calculate eating up that seam of the surface that it's filleting, which is that little patch that was there before, and moving into a new surface. It's just not that robust. Now higher end modelers, something that's using like a Parasolids one, the Parasolids kernel, modeling kernel, has years and years of development put into it that's allowed it to succeed in some of those. But even in those, you can get errors, and a lot of times it has to do with that. Now, the reason that you're getting that seam there is you have these two are segmented right here. You see the 1 and 2 segments. That could just be a single solid entity. So in Bobcat, we can fix that. I'm going to run an arc fit of 0.001 on it, right? And I'm going to select that one, and I'm going to select these two. And what that's done is make that one solid entity now. It combined those two arcs to fit within that. So now if I extrude that, for instance, oh, same distance, yeah. Let's go and make sure so let's say okay. And let's look at my whole object there. There we go. So now I have a nice smooth solid surface going through there, no seam to edit. So I can do the 0.0125, right, or back up, but now I can put 0.25, which is the one that was definitely gonna, now, see what I mean? I can fill it down that whole surface. And same thing here though, if I try to go 0.025 now, it'll probably fail because it's got to cross over these seams and eat up entire surfaces in it, right? The only thing I'll be able to do now is go back down to whatever fillet will fit in that little area there. So anyway, it's just a general modeling rule about creating clean geometry. So if you weren't going to, if you were going to do booleans with this in the future, leaving that little segmented area, like it looks like it's a car rim or something, if you were going to start booleaning things in and out of there, those little surface seam edges and all those little tiny fragment things will eventually start getting in your way if it's going to be something very complex. So cleaning up your initial modeling and stuff like that is a good idea, and it takes just a little bit of time, but will help you down the road as you start doing more complex stuff. The other one that does that, which wouldn't work on that one, but works on line segment and line geometry that's connected tangentially, is reorganize, cleaning up, and optimize. So if you had two lines that met tangentially, which is both going in the same direction, you could select both of those, optimize them, and they would turn into one solid line, which then wouldn't have segments in it. So that's pretty self-explanatory. I guess I'll just do a quick demo here real quick anyway. So let's break that. Let's divide that into, let's make 4 segments, right? Okay, so now we should have 4 segments there, right? So if I had some type of geometry at some point that that had that kind of stuff, I'm getting all those segments on my surface that I extrude. Those will, again, down the road they can interfere, but so arc fit doesn't work on lines, but when you have lines that are tangential like that, then you could go to the reorganize, clean up, and optimize. You can select those 4 lines, and that should have made them all into just one big line again. Now I've removed all those seams for down the road when I start extruding and working. So clean up and optimize won't connect these two together because they're not tangential that way. There's actually a corner point there. And so anyway, that was just something I wanted to point out on your solids down here, something for you to look at. So on all of those, if you just delete those, and you can recreate them quick enough, but clean up those surfaces, and it's just a good point to have for reference. Okay, thanks, bye.